Alright, try this problem out. See what you can get out of it. I'm going to solve it now. First thing you want to do with this problem is go to your book, and you're going to see the way to solve this is you change your derivatives of y, your orders of derivative to y, into powers of r, some kind of arbitrary variable r. So for example, the second derivative of y would be the second power of r. First derivative of y would be just r, and the standard function of y, no derivative, would just be you know, nothing, kind of like r to the 0, just like 1 or something. Another thing is your form should be in a way that has a 1 in the coefficient for the, so let's just plug in the r's first. Let me get there. So r squared minus 20r plus 20 equals 0. So another thing you need for this form is you need the coefficient of your a term to be 1. So we'll divide everything by 10. So that'll be r squared minus 2r plus 2 equals 0. So now the beauty of this form that we just put it in is that we can use the quadratic formula to solve for r. And that'll eventually lead us to our solution, general solution. So I'll just start solving it. R is equal to negative b. In this case, a is equal to 1, b is equal to negative 2, c is equal to 2. R is equal to negative b plus or minus the square root. B squared, which is 2 squared, 4, minus 4. A is 1 times 2. All over 2 to the a, which is 1. So this 2 over 2 will be a 1 plus or minus square root of 4 minus 8 over 2. R equals 1 plus or minus the square root of negative 4 over 2, which will become 1 plus or minus, that square root of negative 4 is going to be a 2i over 2. 2's will cancel. You are left with r is equal to 1 plus or minus 1. Now again, you would check your forms, and it'll show you that when you have let me change the numbers. When this term is less than this term, there's a certain solution. When these two terms are equal, there's a different solution. And when this term is greater than this term, there's a different solution. It depends on these two terms here. Okay, you'll see that in the handbook. So because our 4 is less than 8, we're gonna have our alpha here, our beta here, and then we're going to use the form y is equal e to the alpha x times c1 cosine beta x plus c2 sine beta x. Okay, so now we're basically there. All we have to do is plug in our alpha and our beta values, and we'll have our solution. So e to the alpha x is 1 times x, which is just x. c1 cosine of beta x. Beta is 1 here, so that'll just be x. Plus c2 of sine to the beta x. Beta is 1, so that'll be just 1 times x. And that's your general solution to that diffie q.